Okay, so this is in mineral oil. Typically, it's most of the alkali metals are stored in like mineral oil or kerosene, and you want to try to keep it away from oxygen and water vapor, or just water in general here. So here is a chunk of sodium. Okay, now here's the thing. If you look at this, first of all, no, you're not going to handle this thing here. This thing is very light for its size. I mean, normally if you had a piece of metal this size, it would have a fair amount of weight to it. This thing is lighter than aluminum. Okay, and it feels like there's hardly anything here. And that's one thing about density. It has a very, very low density to it. The other thing is too, like right here's a corner, just the pressure of my thumb, I can smash that. Real simple. It has, if you ever worked with like brand new piece of clay, like in pottery or something like that in your art class, that's about how this thing feels. It's like when you get a brand new block of clay, it's a fairly soft metal here, especially considering you're dealing with a metal. Now, I'm using a metal spatula. Typically it's used for scooping out stuff here. This thing has no sharp edges to it, okay? So this is what I'm going to use to slice this thing, all right? I mean, this thing is, you know, absolutely dull. Now, one thing I want you to do is look at right here. Is it, man, that camera here, okay. Watch right here, and you'll see there's a bright silver color to it, all right? See that?
Oh.
It's very shiny. Let me get another piece here.
And then like it hits oxygen.
As soon as it hits the oxygen, it starts tarnishing almost immediately. So you start getting this white, kind of a pinkish white. And that's basically, it's almost like rust or, you know, tarnish. Get a few pieces here. Pretty, huh? Okay. Now, and again, this stuff is very soft. You know, this size here, I mean, it takes no effort for me to mold this thing here. Let me get one more piece. Why? Because it's fun. See that? Okay. Now, I'll put this back in this container. It's hard to open up the lid when your hand's covered up in mineral oil. And get your mask down. Okay, so now.
You have to put it in the test tube?
What's that?
You have to put it in the test tube?
No.
Again, put it
Oh
over
no.
there.
That would be kind of dangerous. All right, so we're going to come over here.
Shut the thing. This stuff can swing.
All right, so let me swing this thing over here. Yep. Actually, I'm gonna swing this over here. It's out of. Yeah, that's good. There you go. Okay. All right. So right now I have water in there, and one thing I want to draw your attention to is I'm going to check the pH of it. And I'm going to use a universal indicator. And if it's green, it's a base. If it's red, it's an acid. And if it's blue, it's a what they call a base or an alkaline. Right now it's slightly blue. The other classes it's been green. Okay. And it's a little bit more blue side here. Just so we can see a little more of a color change, I'm going to add just a little bit of vinegar to this. Ooh, pretty. Okay. So right now, it's a little bit acidic. It's a weak acid. All right, so now, you guys have cameras, you want to record this? Is this a pretty later? Okay. All right. Now, what I want you to do is pay attention to what happens to the color of the solution as well, okay? Later on in the year, that's going to be kind of an important factor here. I'm gonna put the shield down. What color is the flame?
Red.
Orangish?
Yeah.
And that's one thing, that's one identifying factor about sodium. Sodium always produces an orange flame. Nothing yet. But doesn't melt my petri dish. You done? Okay. Now, a couple things to notice here. Where was it on the water?
It was always on the edge.
It was on the edge, but it was also floating up on top. Okay, that's one of the things about this is that it's less dense in water. Then, if you heard the hissing going on, let me turn this off. If you notice, the water's a little bit more bluish, especially in certain areas here. I'm gonna do this again. But now, one thing to notice about this is that it's kind of roughly a rectangular shape to it. When I put it in there, remember how that one got warm over there? The calcium got really warm. Okay, this thing gets so warm to the point where it turns molten. It generates so much heat from reacting, it will melt itself, and so it turns into a little ball of molten sodium. So now, you hear that hissing? And that's hydrogen gas being produced.
Did it catch on fire this time?
Sometimes it catches fire, sometimes it doesn't, but you notice how it tends to ball up, and it's floating up on top. And the water is now turning blue. The water is now turning alkaline, or it's turning basic.
I like the one that caught on fire better.
Yeah.
Is that
I don't
because there
know
was
why.
acid in there?
What's that?
Or is that because it was that? Like,
Bigger
more
chunk
acid?
or what?
No, actually, it's not always, it's just, sometimes it just does it. I think sometimes when it's throwing sparks, and if it's able to ignite the hydrogen that's forming around it, that's when it's most likely to be able to start catching on fire here. But it's just, I've had times where every single one would catch fire, and other times where none of them would catch fire. So it's just a luck of the draw. Come on. The problem is, it's such a soft metal, it likes to stick to the tongues. Really?
That's bright too.
Sometimes it'll produce a really loud bang.
That was sweet.
Yeah, I like it when it came out of that.
Let me turn on the exhaust.
It's like
Yeah.
purple.
Yeah. So now the water is alkaline.
Put two in at once.
You need a welding. You need a welding mask for that. Jeez.
Now, it's not going to. Sometimes it works, sometimes it doesn't. Here, because they're molten, if they're able to touch, sometimes they'll join into one. But many times, because of the bubbles, they actually will force each other apart. So we'll see. Hang on now. Come on. Ah.
I thought you wanted me to get the other piece.
Yeah.
Together. Go together.
No, we need fire. This is not using fire. There we go. Okay.
No.
When it exploded, that was cool.
Oh, come on. That was cool too.
I mean, it was, but yeah.
Okay, so that is, and if you notice, sometimes, roughly about half the time they would catch fire here, but not always here. So now let's go back over here and look at the last one. All right. So now, potassium.
Big T.
Now, most people have probably never seen potassium metal in person before.
Nope. But well, we are now.
There we go.
Ooh, it's purple.
Yeah. And that's one thing I think is kind of unique here. Not only when it's tarnished is it slightly purple, but also even when it's freshly cut, it's a metallic purple color. And because if you look on the chart, what should happen to the reactivity?
Go up.
It should go up here, okay? So, see if I can zoom in a little bit. Okay. So if I take this, and again, I mean, this is about like chewing gum. It's like one of those, like the big block ones here, okay? It's about like that.
Oh, it's softer than the other one then?
It's softer, this is softer than the sodium, okay? Now, get over here where you can see this surface right here. This is gonna happen real fast.
It's like orange, like a.
It happens, for a moment,
It's real bright.
it's very shiny, but it has a purple, kind of a slight purple color to it. I'm gonna try to do it toward the camera here.
That's quick. That's
Yeah, it is very quick. And especially today when it's a little more humid. Is it showing up on? Okay. When it's a little more humid, it's a little more prone to tarnishing a little bit faster. Do one more. Why? Because it's fun.
Well, that was a good one.
Yeah.
Thick piece right there. That's the last one.
Yeah, that's the grand finale there. Okay.
Yeah, man.
Okay.
Are these expensive?
They're not cheap.
Yeah, I'd assume they're not.
And this one's also kept in mineral oil. When I first came here, we had a chunk and it was kept in kerosene. So it was like this, it was like a thin little rod of this stuff here. And again, this stuff, if you notice, is kind of purplish in color. It's very, very soft. And very light. So let me get some of these kind of laid out here. I'll start with this one here first. Kind of work our way up. Okay, so let's move back over here. And sometimes students wonder why my screen is kind of dirty. Now you know why. Okay. So you want to focus? Maybe? Okay. I think it's trying to focus on the screen. Okay. So now, get your phones ready. Now again, when you are looking at this, one thing you want to see here is that because this thing is generates so much heat, this thing's going to turn into a liquid very rapidly. So it'll turn to molten. All right, ready? When it does that. All right. Notice the color?
Purple.
Has a little bit of purple to it. Notice how quickly it's done? Okay. Try another one.
Big chunkus.
The thing is, if I put just a little bit too much pressure on this thing here, it sticks right to the tongs. All right, here we go.
Oh, that one can explode from that.
Sometimes it does. Which I won't read. Wait on.
Do less when you have the vacuum on?
What's that?
Does it do less when you have that on?
No, I had it off.
I don't know. I'm saying, does it like just the reaction do less? Like, no.
Just kind of clears up the air on the inside. Sometimes you start getting like a fog that forms inside of it. Okay, you guys ready?
Yes, sir.
And that's why I put water on the table.
That's sweet. That one's good.
Yeah, it was like, oh.
Let's move this one here. You guys ready? Is that showing up on the?
No, it's not.
Is it showing up on the video when I do that?
I think so.
You ready? Okay, here we go.
That one with the sodium is sweet.
Okay, we're going bigger now. A little bit bigger. There you go. I like the color.
That one's pretty sweet.
Yeah.
Got one more big cup.
One more. Okay.
Chunk is
This off.
big chunk is.
You ready?
Please.
All right, here we go. Well, that was interesting.
That flame got pretty high though.
Yeah.
That's sweet.
What do you guys think?
That was pretty sweet.
All right, go ahead and get to your seats here.
I think